Welcome to Science Spec. Today, we're diving into one of the strangest ideas in all of science. Seriously, it's an idea that was so bizarre it even made Albert Einstein himself deeply uncomfortable. We're talking about a spooky connection that seems to completely shatter the ultimate speed limit of the universe. So, is faster-than-light communication really possible? Let's find out. Okay, let's just start with a wild question. What if you could link two tiny particles together? I mean, really link them, and then separate them by billions and billions of miles. And what if whatever you did to the particle right here in your lab instantly affected the other one? Not just super fast, I mean literally instantly. Faster than light. Sounds like something out of a movie, right? Well, this is the mystery we're gonna unravel today. All right, section 1, a spooky connection. How can two particles act like one, no matter the distance? You see, this whole crazy idea isn't science fiction. It's a real thing, and it's called quantum entanglement. And it really gets you thinking, how on earth can two separate things be so connected that they basically act like a single object, even if they're on opposite sides of the galaxy? Okay, to get our heads around this, let's try a simple analogy. Imagine you've got a pair of gloves, a left one and a right one. Now, without looking, you put each glove into its own identical sealed box. You keep one and you mail the other one to your friend who happens to live on the moon. The moment you open your box and see, aha, it's the left glove, you instantly, and I mean instantly, know your friend has the right one. Simple, right? Seems obvious. The information was always there. But here's the thing. The universe is way, way weirder than a pair of gloves. Which brings us to our next part, Einstein's big objection, or why the world's smartest person called it spooky action at a distance. Yeah, that glove trick seems pretty straightforward, but quantum entanglement is so much stranger. It was so weird, it genuinely bothered Albert Einstein. He was convinced it just couldn't be right. And this really gets to the heart of Einstein's problem. He, along with his buddies Podolsky and Rosen, basically argued that nothing, absolutely nothing, can travel faster than light. That's the cosmic speed limit. So this idea that you could measure one particle and instantly influence another one light years away, to him, that broke the most fundamental rule of the universe. He believed everything had to be local. You can only be affected by what's right next to you. He was sure that quantum theory was missing something. So this set up one of the biggest showdowns in the history of physics. On one side, you've got Einstein's common sense view. He thought the particles were just like those gloves. They had hidden instructions from the very start. One was always going to be spin up, the other was always going to be spin down. We just didn't know which was which until we looked. But on the other side, you have the truly spooky quantum view. This says the particles aren't a total haze of possibility. They have no definite state until you measure one. The very act of looking at one instantly forces the other one to snap into its opposite state, no matter how far away it is. Wild. So for decades, that's all it was, a huge debate. Was reality predictable with hidden information, like Einstein hoped? Or was it really this weird? Nobody knew for sure. That is, until some brilliant scientists figured out a way to put it to the ultimate test. So how did they finally get an answer? Well, it happened in a few key steps. Back in the 1960s, a physicist named John Stuart Bell came up with this amazing mathematical test, a way to tell for sure if Einstein's hidden variables could exist. Then, in the 70s and 80s, guys like John Clauser and Elaine Aspect actually built the experiments to run Bell's test. And their work was so unbelievably important that in 2022, they, along with Anton Zeilinger, won the Nobel Prize in Physics for it. A pretty big deal. So what did they find? What was the big answer? Every single experiment, every single time, proved the same thing. Einstein was wrong. The universe really is that weird. The spooky connection is real. There are no hidden instructions. Okay, so this brings us to the most obvious question, right? So, no FTL messages. The universe's biggest loophole has a catch. If this connection is instant, can we use it to build, a faster-than-light internet? Can we text our friends on Mars with zero lag? It seems like a massive loophole, but there's always a catch. And the answer, according to a rock-solid principle called the no communication theorem, is a big, fat no. But wait, why not? If it's instant, it should work, right? Well, here's the rub, and it's all about randomness. See, When you measure your particle, you can't choose the outcome. You can't force it to be spin up to mean a 1 and spin down to mean a 0. The result you get is totally random, like flipping a coin. Your friend on the other side of the galaxy, they also see a completely random result. The spooky part only shows up later, when you call each other up on a regular, old, slow-as-light phone line and compare your lists of random results. Only then do you see that your results were perfectly correlated, but you couldn't send a secret code in real time. Okay, so no faster-than-light group chats. That's kind of a bummer. But what can we do with this incredible phenomenon? Well, the answer is just as cool, if not cooler. It's something called quantum teleportation. And yes, teleportation is real. Now, hold on. This isn't like Star Trek. We're not beaming people or objects around. What we're teleporting is information, the pure quantum state of a particle. It's a process where the exact blueprint of one particle is transmitted to another location and rebuilt there, while the original is destroyed. The information is kind of beamed across using that spooky entangled connection. And get this isn't just some sci-fi theory. Just a little while ago, in 2025, scientists hit a major milestone. They successfully teleported quantum information over a distance of 30 kilometers. And the coolest part? They did it through a standard fiber optic cable that was also carrying normal internet traffic at the exact same time. That's a huge, huge step toward building a real quantum internet. So we have this spooky connection, it's real, but we can't use it to talk faster than light. So what is it? What is this invisible thread connecting two particles? The latest thinking on this is maybe the most mind-bending idea of all, and it might have something to do with wormholes. Yeah, I said wormholes. It boils down to this incredibly simple-looking equation. ER equals EPR. Looks harmless, but it might be one of the most profound ideas in all of physics. Okay, so what on earth does that even mean? Well, ER stands for an Einstein-Rosen bridge, which is just the fancy technical name for a wormhole. You know, a tunnel through space-time. And EPR, that stands for Einstein, Podolsky, and Rosen, the guys who first wrote about entanglement. This ER equals EPR idea suggests that maybe these two things are the same thing. That two entangled particles aren't just magically connected, they might be literally physically connected by a tiny microscopic wormhole. Just think about that for a second. The spooky action isn't a signal traveling through space. The entanglement is a connection of space itself, which leads to this absolutely wild idea. Could the entire universe be stitched together by a massive network of these tiny wormholes, all powered by quantum entanglement? So we've gone from a simple pair of gloves all the way to the very fabric of space and time. And the big takeaway here is that the spooky action isn't just some weird little quirk. It's a fundamental clue to how our reality actually works, connecting the tiniest particles to the grand structure of the cosmos itself. Thanks for watching this explainer. If you enjoyed this journey into the quantum world and you want to explore more of the biggest and weirdest ideas in science, do me a favor and subscribe to Science P. It was great having you.